All right, so this video was requested by my second period. This is the worksheet, Imagine the Possibilities for Domain and Range. All right, so let's go ahead and get right into it. So this first one, we know that it's discrete. So I'm going to write discrete on here. We know that because it's a scatter plot. Okay, so it will be easy to label our axes so we can know what it's going by. So our x-axis is going by 0.5. So I labeled every other one. Okay, and my y-axis is going by 0.25. Okay, we know that because it's 4 spaces in between each number. So I'm going to just label my 0.5s here. Okay, so we know domain goes left to right. So I'm really going to be looking at my x-axis. And my first number will be 1.5. Then my next number is 2, followed by 3.5, 4, and then 9. So that's my domain. Okay, and then my range, I'm going from bottom to top. So I'm going to say that's 0.25. This is 0.5. This is 1.5. This is 3. And this is 4.25. Okay, and that's number 1. Number 2, this is pretty straightforward. Our domain is our x. So we have -3, -1, 0, 1, and 2. Okay, that 1 or that -1 repeats, so we don't need to write it twice. Then I have -2, 4, 7, 3, 5, 5. That repeats, so again, just write it once. -2, 4, 7, 3, 5. All right, so this next one, it said Winnie is driving at a constant rate. It takes her 4 hours to drive 232 miles from her home in Dallas to her parents' house in Houston, Texas. She creates a graph of distance versus time for the trip using the equation D = 58t. Okay, so the first thing I want to do is I want to decide, or I want to figure out, what do my variables stand for? Okay, so we're talking about this girl. She's taking a trip to her parents' house. She's going to be driving to Houston. Okay, so they gave us distance versus time. So we know that our x will stand for our number of hours. And then depending on the number of hours that she drives, that will determine her distance. And our distance is in miles. Okay, so we know that this trip takes her 4 hours. So we know that that's going to be our maximum. Time always starts at 0, so we're going to have 0. Now, in order to finish writing out my domain, I need to know, is this continuous or discrete? So remember, continuous we can measure, discrete will be we can't measure it. Okay, so we're talking about time. So time is always continuous. Okay, so basically I know that this trip is 4 hours because, like I said in class, time goes on and on and on. Okay, she's not gonna stop and at 1 hour her car is just gonna pop on the freeway. Okay, she has to back out her driveway. She has to get her gas. She has to do all these things before she gets on a road to go to Houston, Texas. So this is continuous. Okay, then we know her total trip was 232 miles. Okay, and we know that distance for this starts at 0. So this 0, 0 will represent when she's in her driveway, like I said, packing her bags, putting everything in a trunk. She's probably telling all her family bye, or maybe they're coming with her, but they're all getting in the car and they're getting ready to start this trip. Okay, so I'm going to put Y, and I'm going to have my signs. Now, the reason why it gets the greater than or equal to on this scenario, and most real world scenarios will have the greater than or equal to, but you have to think of it as time actually starts at 0. Okay, and she's actually somewhere after 4 hours. So 4 represents her getting in Houston, Texas. So she's at her parents' house, she's in the driveway, she's there. So 4 actually exists. 0 actually exists because, like I said, that indicates when she started that trip. Okay, all right, this one here, a lot of y'all were confused on this one, so I'm gonna put a 0 here so we don't get confused. That's our origin. So for my domain, I'm gonna draw these lines because I want to know where I start and where I stop. So since they gave us time and height, I'm gonna make a little scenario. So let's say, and this is a scenario I used in class. So we are playing volleyball and she's about to serve this ball. I know that drawing looks kind of funny, but let's say she served this ball and it went from her hand all the way here up to reach its max, and then it went down to the ground. Okay, so basically, if I'm looking at domain, I'm looking at the time that it was in the air. Okay, a lot of people put 10 because they saw that 10 there as the y-intercept. This point is 0, 10. So I have to put 0 for my time because time starts at 0. And then the ball will be on the ground at 9.5. Okay. Again, it's a real world scenario. It's going to be equal to because those times are included with our domain. Now, range is our distance. So this will represent from the moment it hit the ground, or we're kind of going backwards here because it hit the ground last, but we're looking at the total distance that the ball was in the air, all the heights that it reached. Okay, so this is 0 to 22.5. Okay, so that's my range. Okay. Number 5. Okay, so I'm going to draw my lines. I'm going from -6 to 2 for my x. Okay, x in the middle. Like I said, always less than signs for compound inequalities because we read it from the middle. And I have an open dot. I'm sorry, closed dot. So I have equal to. And I have another closed dot. So I have another equal to. So my x values are greater than or equal to -6 and less than or equal to 2. For range, bottom to top. -4 and then 1. Remember, you want to start with that lowest number first, and then I have my signs and I still have my closed dots, so I have equal to. So my y values are greater than or equal to -4 and less than 1. All right, a senior citizens group is making fruit basket and plans to sell them as a fundraiser. They are able to make fruit baskets and want to sell them for $35 each. Okay, so we're reading about these are some senior citizens. They're trying to sell fruit baskets to the community. So they may have some, I don't know, apples, mangoes, bananas. They may have all these fruit. They probably grew it in their garden in their backyard because, you know, a lot of people, senior citizens, have gardens. Okay, but anywho, you want to figure out what is your X and your Y. Okay. So you pretty much want to, let's make a table. Okay. So X will represent our number of baskets. And depending on the number of baskets they sell, that will represent their profit or the money that they made. Okay. So it said they want to make 10 baskets. So 10 is going to be our max. So I'll put that down here. Okay. Now, since 10 is our max, I want to ask myself, what's the minimum amount of baskets that they can sell? That's going to be 0 because they can sit up and they might not make any money. People might not like their fruit, or I don't know, maybe it's rotten. I don't know. But We're going to be starting off at 0. Okay. Now, before we continue, we want to think about, is this continuous or discrete? We're selling fruit baskets. So they cannot sell half a basket. So this is going to be discrete. Okay. You're not going to be able to go to this table and say, hey, lady, I want to get 2.2 baskets. And they say, okay, hey, here you go. I'm going to just give you a banana. No, they're not going to open their baskets and do that for you. They want you to buy the whole basket for $35. Okay. So I'm just going to add this up. If I sell 0 baskets, I make $0. Okay. Let's go ahead and just put in all these numbers here. 7, 8, 8, 9, 10. Okay. So each basket I sell is $35. So I could just multiply it or add it each time, depends on what you are comfortable with. So my first number, if I sell 1 basket, I make $35. 2 baskets, I make $70. 3 baskets is $105. 4 baskets is $140. 5 baskets is $175. So as you see, I'm just adding 35 each time, and that's representing our range, which is how much they made per each basket that they sold, okay? So if you have a calculator, this will be a good time to pull that out, or maybe you can do this in your head. Okay, and their last number is 10. I'm sorry, 10 baskets, they made $350. Okay, so if they sell 10 baskets, they make $350. So this is our domain, which I'm not going to rewrite that. You can rewrite that so you know that that's domain. And this is our range. Okay. Now this one here, it says prime numbers. Okay. So everybody was confused on prime numbers because we learned that in 8th grade. Prime numbers are numbers that's divisible by 1 in itself. So let's make a table. Okay. And I do want to make a correction. 1 is not a prime number. 1 is not prime or composite. So we're going to start with 2. Okay. So we got 2, 3, 4 is not 1. We got 5, 6, 7, 8, 9, 10, 11, and 13. Okay. And then what I want to do here is pretty much make a table of my Y values. Okay. Okay. So basically, X is our independent variable, right? So we're plugging in each X where X is, and we're finding our Y. So you're going to plug in each number like so. Okay, and I'm just going to say, okay, negative 4 times 2, that's negative 8, minus 10, that's negative 18. So when X is 2, Y is negative 18. Okay. And I'm going to let you keep going on that because I'm running out of time on this video. But you want to basically do that for all of your numbers. Okay. You may want to even use the calculator so you don't have to use all that scratch work. All right. Then this last one is pretty self-explanatory. This is our domain, -3, -1, 1, 3, and 5. And our range is 3.5, 3.75, 4.25, 4.75, 5.25. All right. Brackets that I can't draw. And that's it.